Come on in and have some fun. So just come in and learn with us with the mouse in the house.
Hi guys, my name is Max. Welcome to my lab. Today, we're going to make a matchstick boat by using the surface tension reducing properties of soap. For this experiment, you will need matches, a bar of soap, and water in a large flat bowl. You can also try this in the bath. Let's begin! Ask your parents to cut a slight notch into the back of the match. Take a thin slice of soap and put it into the notch on the match. Pour some water into a large dish and carefully place the boat onto the water. See how it moves. Wow! Your own boat using only a matchstick.
What's in the soap that makes it move?
The soap molecules break down the surface tension of the water, creating currents at the back of the match, which acts like an engine propelling it forward.
Can you use any soap?
Yes, but some soaps work better than others. Try using liquid soap. Wow, look at that! Now let someone else try. Remember, you need to replace the water each time you try this, as the boat will move until the water's surface is covered with a layer of soap. Dip the matchstick into the liquid soap and carefully place it onto the water. Watch it go! So now you can turn a simple match into a moving boat. Imagine your matchstick boat is cruising down a river. This same principle helps when you're washing the dishes. Water and grease do not mix. But when you add the soap, it allows the grease to dissolve in the water and you can rinse away dirt under the tap. Twist and tangle up your own mouth with tongue twisters today. 6 thick thistle sticks. 6 thick thistle sticks. Find out about more groovy science projects next time. Bye for now. Together with our studio members, we're going to build a simple egg steamboat. For this experiment, you will need a chicken egg, wire, a candle, wire mesh, a syringe, water, a tinfoil container, and glue. Let's begin. Pierce 2 holes in the egg on either side using the wire. Make the one hole slightly larger than the other. Blow into the smaller hole until all the contents come out. Ew! Make sure the egg is really clear by cleaning it with water as well, before continuing. Add glue to close up the larger hole and then let it dry. In the meantime, take your tin holder and bend it into the shape of a boat. Bend the wire mesh to make a platform for the egg. Fill the egg with water through the small hole using the syringe. Now, under adult supervision, light the candle and stick it to the bottom of the boat. Then place the wire frame over that and the egg on top of the wire frame. Wait for the water in the egg to start boiling and produce steam. This is how a real steam engine works. Now you can place your steamboat in the water and watch it go. The flame boils the water inside the egg and creates steam which escapes out the small hole, propelling the egg boat forward.
Why do you need to close one of the holes of the egg? And does the size of the hole matter?
You need only one hole so that it can propel forward. The smaller the hole, the faster it will go.
Do you have to use an egg for this experiment, or can you use something else?
You can use any hollow object such as a tin. Your tin. Make 2 holes on either side of the egg. Now, blow all the contents of the egg out until it's empty. Glue the bigger hole closed and then fill the egg with water. Get your parents to light the candle inside the boat and place the egg on top of the wire mesh. Wait for the water inside the egg to boil and watch the boat move. Test your skills with today's tongue twister. Cheap ship trip. Cheap ship trip. Well, that was another great experiment. Bon voyage! Today, I'm going to show you how to make a fireworks display underwater. Wow, look at that! For this experiment, you will need a large empty glass, water, cooking oil, droppers, a small empty glass, and 3 different food colorings. Let's begin! Pour the water into the large glass and then pour the oil into the smaller glass. Using the droppers, put a few drops of the different food colorings into the cooking oil. Be careful not to spill! Notice how the food coloring does not mix with the oil. Now stir the food coloring and oil together. Look how the food coloring droplets break up into smaller drops. Pour the solution into the glass with water and see what happens. Watch as the food coloring droplets sink to the bottom, forming different colors. That's so cool!
Why doesn't the food coloring mix with the oil?
Water and oil do not mix, as oil is less dense than water.
Why does the water droplets spread out and not just drop down?
The droplets are spreading as they are breaking the surface tension of the water.
Can we use any other colors or containers?
Yes, you can use as many different colors and different shaped glasses as you want. Try that and enjoy! Now it's your turn. Add the food coloring droplets to the oil and stir. Watch now as you add this to the water. Oil and water do not mix, but the colored droplets break down the surface tension of the water, creating a fireworks display. Now try today's tongue twister. Singing Sammy sang songs on sinking sand. Singing Sammy sang songs on sinking sand. Now go out there and amaze your friends. See you next time. Today, we're going to get our hands sticky and make green monster slime. For this experiment, you will need PVA project glue, a weak solution of borax, food coloring, a dropper, and a stick to stir. First, add the food coloring to the PVA glue solution and stir thoroughly. PVA is used in the manufacturing of paint or wallpaper glue, and you can get it from any hardware store. Add the borax to the green PVA solution. Your mom might use the borax solution for whitening the washing. Stir until all the liquid is dissolved. Ew, it's so slimy. You see, science can be fun. Wow, look at that! What fun!
Is the slime a liquid or a solid?
PVA is a type of plastic or polymer. When you add borax, it joins the polymer strands to form a non-Newtonian liquid, which means it's both liquid and solid.
What other colors can we make?
The food coloring makes the color, so you can make monster goo in any color you like. Let's do it again. Add the green coloring to the PVA glue solution. Stir in the borax until it is totally dissolved and the mixture goes thick. Now you have slime. Pour it out on a slab and have fun. Watch it slip and slide through your hands. That looks fun. Be careful not to add too much borax, as your slime will turn back into a liquid. You can make your own monster goo and keep it in a sealed plastic bag to show your friends later. have more fun with a new tongue twister. A big black bug bit a big black bear. A big black bug bit a big black bear. Well, that was another great experiment. See you later. Ever wanted to be a secret agent? Now you can send invisible secret messages to your friends using magic ink. For this experiment, you will need cornstarch, a small paintbrush, a stick, water, and some iodine solution, which you can buy from any pharmacy. Let's begin. Take a teaspoon of cornstarch and mix it into the water. Stir well. You want to make a thick paste. Dip your stick into the cornstarch solution and then write your secret message down. Let it dry. With your paintbrush dipped in the iodine solution, brush over the paper to reveal the hidden message. The message should appear in a dark color. Wow, it's magic!
Why does the iodine make the writing show up?
Iodine is an indicator which binds to the starch to reveal the message. Play this with your friends. Take a teaspoon of cornstarch and stir it into the water. Remember to stir well. Caution, remember the iodine solution is poisonous. So girls, what secret message are you going to write for the boys? And the boys must write a secret message to the girls. Swap the messages and use the iodine solution to uncover your hidden note. So girls, what does it say? What does it say? Could it be a secret meeting place? Try using other starches instead of cornstarch, such as diluted mashed potatoes or mashed cooked rice with water. Now you make your own magic ink at home and send secret messages to your friends. Ooh, look what the girls have to say. Is it true, boys? Look what my secret message is. Me! Twist your tongue around this. Shy Shelly says she shall sew sheets. Shy Shelly says she shall sew sheets. Find out about more groovy science projects next time. Bye for now. Some things just don't mix. Dogs and cats, oil and water, needles and balloons. With a little science, you'll be able to make a magic balloon by sticking a needle through the balloon without popping it. For this experiment, you will need a balloon, a needle or stick with a sharp point, and some dishwashing liquid. To begin, blow up the balloon but not too much. Tie a knot at the end of the balloon. Dip the tip of the wooden stick into the dishwashing liquid, which works as a lubricant. Place the sharp tip of the stick onto the thick end of the balloon near the knot and push the stick into the balloon. Push the stick in all the way through the balloon until the tip of the stick touches the opposite end of the balloon. Be careful not to jab yourself. Keep pushing until the stick penetrates the rubber. Breathe a huge sigh of relief because it didn't pop.
Why doesn't the balloon pop when you put the needle through it?
The trick is to pierce the balloon better. Lesser leather never weathered wetter weather bitter. And that's what science experiments are all about. See you next time! You've heard about color mixing. What about color unmixing? Today, we're going to separate candy colors and find out what different colors are used in making the candy you eat. For this experiment, you will need candy with different colors, water, coffee filter paper, and scissors. To begin, take a few drops of water and add it to the candy to release the color. While they are soaking, cut a thin strip of filter paper for each of the 3 colors. Place the end of the filter paper into the dishes. Give the color about a minute to soak up into the paper. How many different colors can you see? You may think that the candy is brown, but when you see the breakdown, brown is actually made out of blue, red, and yellow. Orange is just orange, and green is made up of blue and yellow. Candy contains dyes, and as they pass through the paper, the dyes are separated. The colors separate because those colors that are lighter are drawn to the top. This process is called chromatography.
Can you use any type of paper?
Yes, as long as it's absorbent paper.
Why can't you add more water?
That will dilute the colors and they won't be visible. Now you try. Put the different colored candy into the dishes. Add a few drops of water to each different dish. Cut the absorbent filter paper into strips and place them onto the colored candy. Watch how the colors are separated and move up the filter paper. Have a closer look. Now you can clearly see the makeup of the colors. You can also use chromatography to separate the colors in markers, food coloring, and powdered drink mixes. Come on, let's try a new tongue twister. A noisy noise annoys an oyster. A noisy noise annoys an oyster. Now go out there and amaze your friends. See you next time. It's easy to turn an ordinary soda bottle into a soda fountain. For this you will need a 2-liter bottle of soda drink and Mentos. All you need to do here is drop the Mentos into the soda and move well away. To create a bigger fountain and extra flow, you can add a tube or an attachment big enough so that you can add more than 1 Mentos to the soda at the same time. Okay, now drop the Mentos into the bottle at the same time and then get moving. What a fountain! Carbon dioxide gas is dissolved in the soda liquid. When you add the Mentos, their roughness provides centers where the gas can come together. This increases the pressure and the soda shoots up.
Which is the best mint to use?
The best Mentos to use is the green one.
What is the best fizzy drink to use?
Actually, Diet Cola is the best, and it's also not as sticky. This activity is probably best done outside. Now you try. Carefully open the bottle of soda and place the tube onto it. Position the bottle safely on the ground so that it does not tip over. Warn your friends to stand back. Okay, now drop the Mentos into the bottle at the same time and then get moving. Watch out! You might get wet and sticky. Wow! Look how high the cola went! Remember not to show off with this experiment in your mom's lounge. Now go out there and amaze your friends. Now today's tongue twister is... Friendly Frank flips fine flapjacks. Friendly Frank flips fine flapjacks. Well, that was another great experiment. See you later. Scientists can tell if a substance is an acid or a base by means of an indicator. This experiment will teach you how to make your own cabbage juice indicator. For this, you will need a red cabbage, a sharp knife, vinegar, water with bicarbonate of soda, household ammonia, a large jug, and a dropper. Let's begin! Slice the cabbage and put it into a jug of water. Now boil the cabbage for about 5 minutes until most of the red juice is extracted from the leaves. Once you have the cabbage juice, use the dropper to add a few drops to each of your household solutions. Wow! See how the colors change? The water is neutral, and so the indicator stays the same. The ammonia goes green, so now we can deduce that it is a base. The water with bicarbonate of soda goes blue, telling us that it is a weaker base. The vinegar goes pink, so this tells us that it is an acid.
Why do the colors change?
The color in the cabbage leaves is an indicator. When an indicator is applied to certain solutions, the colors change, measuring the strength of the acids and bases.
What other vegetables can you use?
You can use turmeric, beetroot, or even some flowers like rose petals. Now you experiment. Start by boiling the cabbage leaves. Make sure you always have adult supervision. Add a few drops of cabbage juice to an acid like vinegar and see how the color turns pink. Now add a few drops to a base like ammonia and watch how the solution turns green. Have fun and see what colors you can make by mixing all the solutions together. Can you guess if your final mix is an acid or a base? You've heard about how acid rain is destroying the environment. Collect a sample of rainwater and test its acidity using your cabbage indicator. Now today's tongue twister is red lorry, yellow lorry. Red lorry, yellow lorry. Red lorry, yellow lorry. Well, that was another great experiment. See you later.